So on this video, we're going to take a look at a rational inequality. So to solve a rational inequality, first we need to find all the x values that make the rational expression true. Okay, so if it's greater than or equal to, then positive or 0. If it's less than or equal to, then it's negative or 0. So remember, 0 only applies if it's equal to, right? So it depends on the inequality we're presented with. So if you look down here, we're presented with greater than. So in this problem, we're going to be looking for positive values or 0 because it's greater than or equal to 0. Okay, so if they gave you a less than or equal to 0, that'd be the opposite. You were looking for negative or 0. All right. So a rational expression can only change signs at the x values that make its numerator or denominator 0. Okay, so this is why we're going to look for, we're going to plug some numbers in a moment to make that kind of make a little more sense here. So first we're going to find the zeros of the numerator and the zeros of the denominator. So zeros of the numerator, we're just going to take the numerator and set it equals 0, and we're going to solve. So we're going to subtract 2 from both sides. Negative x equals negative 2 because these 2's canceled, right? So it's just the negative 2 dropped down, but I have to move that negative over to the other side, which makes them both positive. So I have x equals 2. So this is my numerator 0. Now I'm going to do the denominator 0. So I just take the denominator again, set it equal to 0, and I'm going to add 7 to both sides. So I have x equals 7. So what this does is the values x equals 2 and x equals 7 split the real numbers into the following intervals. We have the one interval in the middle, you can see the 2 and the 7, but then I also have two intervals on the left, one on the left and one on the right. So what this does is it could be 2 to negative infinity, or it could be 7 to positive infinity. So we need to figure out which interval, which one is going to be the correct one, or if there's more than one. So for each interval, the rational expression will always be positive or always be negative. So we're going to choose a test point in each interval and evaluate the rational expression at that value. So when we choose a test point, it doesn't matter what test point we choose. We don't really want to choose 2 or 7. We want to choose something either less than 2, greater than 7, or in between here. Okay? Because if you choose 2, well, that kind of is both of these. Or if you choose 7, it's both of them. You want to choose something in between. Okay? And the sign of the rational expression at the test value tells us the sign for the entire interval. And remember, we're testing it because we want to see, we're looking for things that are greater than or equal to 0. So if I test a point here, say like 3, or not 3, sorry, this would be like 1. If I tested a 1 or 0, something like that, and I had negatives, well, that wouldn't work. Or if I had positives, okay, that interval works because I'm looking for positives. Okay, so we're choosing a test point so that we can see, is that interval going to be negatives or is it going to be positives? Or 0, because it can also end up 0. The solution is the set of all x values that make the rational expression positive or 0 because of the inequality sign in this problem. Remember, that might change to negative or 0 if it was a less than. Okay, so keep that in mind. This problem is positive or 0. All right, so let's choose our test points. So here I re-put our intervals in this table, and we're going to choose a test point. You can choose any test points you want. You do not have to choose the same ones as me, but I'm going to go ahead and choose 0, 3, and 8. So 0 is between negative infinity and 2. It's not 2. And then I just went ahead and chose 3, so I could choose 3, 4, 5, or 6. Wouldn't have mattered there. And then I just went to 8 on this one. All right, so now I'm going to plug in zeros here. So negative 0 is just 0. 0 is also 0, so I end up with 0 plus 2 and 0 minus 7. So just 2 over negative 7, which does mean that it's negative, right? Because I have one negative here. So this is negative values. This means I don't really want this interval because it's not positives. So now let's plug in 3. So I have negative 3 plus 2 and 3 minus 7. So I end up with negative 3 plus 2 and 3 minus 7. Negative 3 over negative 4, well, 2 negatives gives me a positive. So these are positive values. All the numbers within this interval will be positive. And then 8, because it's between 7 and infinity. So I'm going to plug in 8. So I get negative 8 plus 2 and 8 minus 7. And negative 6 over 1, well, that's negative, so that's negative values again. So the only interval that works is this 2 and 7. They did also ask us to put this in interval notation. So this is a way of stating the solution using parentheses and or brackets. Okay, so a bracket indicates a value is included, where a parenthesis indicates the value is not included. Okay, so it's just, we use brackets and parentheses just like you can see down here. So if more than one interval is used, then you use this U shape. It doesn't look quite like a U, it doesn't have the little lines on it, but it's a U to be placed in between them, and it indicates a union. So if you had more than one interval that worked, you would use the brackets and the parentheses, but you'd also have a U with another piece in here. So remember, 2 is included, although 7 is actually not included. And 2 was the numerator when we found the 0 for the numerator. That's okay to have a 0 in the numerator. But 7 is not actually included because it makes the denominator 0. And remember, you're not allowed to divide by 0. That gives us an undefined value. So when we put it into bracket notation, I can put the bracket here for 2. 2 is included, but I put the parenthesis here for 7 because 7 is not included. I can't actually choose 7. Okay, so this was solving a rational inequality. I hope that helped, and I will see you in the next video.